Segment today here at the Smash News Network, least busted name in news, so let's get to it. We're going to blast through some cosmology stuff, and cosmology has been a blast lately. It's been super interesting. Too much to cover everything. So let's zoom out to the intergalactic scale, and we're really only showing you the interstellar scale here. I would invite all of our viewers to plasmascape.com and check out the interstellar chimney. We talked about it yesterday. If you didn't see yesterday's cosmology segment, check it out. You can find all of our playlists at youtube.com/smashamash/playlists. And if you're new to the channel, press like and subscribe. First thing we're going to do is look at some cosmic ray monitors. Here is Apatity and Barentsburg. So the Apatity cosmic ray monitor looking slightly down-ticked here over the past 30 days. Barentsburg, similar downtick over the past 30 days at Barentsburg. Let's go quite a distance farther south to Athens, Greece. By the way, fascinating article about cosmic rays and the relationship between co-rotating regions. Magnetic flux ropes. And you can see a bit of a downtick here at, well, actually, a small uptick there at Athens. So you can see the current data right there, a tiny little uptick at Athens, almost flat. And we'll go even farther south to Mexico City. There's the Mexico City neutron monitor, cosmic ray monitor. And a small, tiny downtick there over the past 30 days as well. And next we'll go very far north and very far south to Oulu, Finland, and DOMC Antarctica and DOMB. So there's Oulu. Oulu's a slight downtick over the past 30 days. DOMC, slight downtick over the past 30 days. And DOMB, a slight downtick over the past 30 days. That's our cosmic rays section. And check out the astronomy picture of the day. It's pretty good. It's good enough to save. And since we're streaming live, you're going to have to see some behind-the-scenes stuff. Oh my God, he's saved an image. It's the NASA photograph of the day. It's Scorpius. And quite an interesting nebula here as well. Anyway, it contains the star Antares, seen here. Anyway, if you want to look at the astronomy picture of the day, apod.nasa.gov. And let's pick a random number here. Today's random number is 146, which coincides with some object here at the Neil Gorell Swift-Bat X-ray Observatory. 146 is NRAO 190, a quasar, which used to be my favorite type of object before we knew what they are. As in the late 90s, we were not aware that quasars were galactic cores. Anyway, there it is. NRAO 190. And let's take a look at it on Simbad and link to Aladdin Light. So quasars are a type of active galactic nucleus where the galactic polar jet is oriented directly toward you, the viewer, which makes it look like a very, very, very bright star. But they are indeed galaxies. This one's probably at a great distance as it's pretty dim. Does it show up in infrared? Well, indeed it does. Let's take a look at the other end of the spectrum, X-ray. And it doesn't seem to show up in any of those. Fermi, by the way, is the gamma ray sensor network. And here it is in UV. And it does indeed show up in ultraviolet. How about on the pan-stars in optical light? And there you go. It's a pretty full spectrum view of that quasar. Again, it looks pretty dim, which means it's probably pretty distant. NRAO 190. And it's actually been increasing its X-ray range here over the past, I'll say, 10 years. Anyway, those are the X-ray transient outputs. We actually saw a big burst from it here. Just about a week ago. You can see a big, significant burst there of fairly dense X-ray emissions, which is what the Neil Gorell Swift-Bat X-ray Observatory looks at. It is for hard X-rays, and it monitors 1,050 different sources Check that out if you like, the Neil Gorell Swift Observatory. And check this out. As I forecasted, largest structures in the universe show clear light-shifted signal of rotation. So, yes, indeed, the filaments in between galaxies appear to be rotating. Now, this artist made like a perfect-looking Birkeland current there, which is fascinating. But in any case, turns out these filaments are hundreds of millions of light years in length, as I forecasted a couple of years ago. And it's because of the physics associated with galactic outputs. So a great article here on phys.org. Largest structures in the universe show clear light-shifted signal of rotation. So we can actually look at the motion of these large-scale filaments by looking at the polarity of the light coming from the objects within them. So a fascinating story here, and not really that much of a surprise that all of these things are rotating. They're also precessing. And let's talk about magnetic flux ropes. Another fascinating article on phys.org about how coronal mass ejections reduce cosmic ray input on the Earth. Yes. And it has to do with the fact that plasma flying through space at high speeds has its own magnetic field. And so I did highlight this quote from the article here. The solar activity currently near the minimum, it causes a disproportionately large geomagnetic storm where there is a high-speed wind catching up the magnetic flux rope expected to interact with it. So, on a CME event, huge amount of coronal material released with a bundle of the solar magnetic field called magnetic flux rope into the interplanetary space. Magnetic flux rope moves through interplanetary space while expanding. And CR density is low inside of it because of originally coronal material. In other words, it's fairly diffuse gas, but it's highly charged material. So it sort of has its own little independent magnetic field. And of course, cosmic ray counts decrease as a result, which is called the four-bush decrease. Check out that article if you weren't aware of this. The four-bush decrease being talked about at Siowa Station. By the way, again, check out yesterday's Cosmology segment if you didn't. YouTube.com/smashamash/playlists. Cosmology segment, Boundary of the Heliosphere, mapped for the first time, and that is today's Cosmology segment. Thanks for tuning in, Twitch. And we'll have to say goodbye to Twitch, and we'll bring you back for the meteorology segment.